Hey guys, Miss Gill here. We are moving on to lesson 2.2, characteristics of quadratic functions. So by the end of the lesson, you should be able to use properties of parabolas to graph quadratic functions, identify characteristics of quadratic functions and the graphs, and use characteristics of quadratic functions to solve real-life problems. So let's just get into it. So we have talked about this before, but just as a reminder, an axis of symmetry is a line that divides a parabola into mirror images and passes through the vertex. All right, because the vertex of this equation is HK, the axis of symmetry is the vertical line x is equal to h. So the x value of your vertex is your axis of symmetry. All right, previously you use transformations to graph quadratic functions in vertex form. You can also use the axis of symmetry and the vertex to graph functions written in vertex form. So we're going to start off with graphing this function using vertex form. So let's just state our vertex. So remember, up here it's h comma k. So also think about if we were going to graph this, we would go to the left and we would go up. That would take you to your vertex. So that's one way of thinking about it too. So our vertex is -3, +4. Remember, this is always the opposite because this is negative. All right, so let's graph it. We have -3, 1, 2, 3, 4. So here's our vertex, -3, +4. All right, we now know our axis of symmetry. So our axis of symmetry goes right down here. This is where x is equal to -3. All right, that just says axis of symmetry. So now we need another point, okay? How do we figure out another point? Well, let's go close to our vertex. So let's go -2. So we're going to plug in -2 into our equation. So I'm using this equation, plugging in -2. So we got -2 times -2 plus 3. We're going to square it and add 4. So -2 plus 3 gives us 1. 1 squared is 1, and 1 times -2 is -2. So -2 plus 4 is +2. So this tells us that the point -2, comma 2, that's a comma, is on the graph. So -2, comma 2, point on the graph. If we know a point that's 1 away from the axis of symmetry, we know this point too, right? It's the same. So because these are pretty close together, let's try another one. So let's go one more out. Let's go to -1, plug it into our equation, and give it a try. So I want you to pause the video. I want you to plug in -1 for f of x and find another point on your graph. All right, so you would have got -1 plus 3 is +2. 2 squared is 4. -2 times 4 is -8. Plus 4 is -4. So we now know the point -1, comma, -4 is on our graph. So again, we have 2 away from the axis of symmetry. We can go 2 away on the other side. And now we can draw our graph. All right. So, Ms. Gill, we get to use graphing calculators. We can use Desmos. Why do we have to know how to graph this? So you understand it better. If you know how to graph on your own, you will understand the transformations and everything that we do in class a lot better. All right. All right, let's move on. Example 2. Notice I have some information here. I don't put these on here just because I like pretty pictures. I put these on here because these help you a lot. They give you some information. So when you are working on your practice, you should be coming back to these and using them. All right, and we're going to talk about them as we work on the next 2 practices. So this one are examples. This one helps with this one. This one's on the next page. All right, so we're graphing. We're labeling the vertex. We're going to label the axis of symmetry. But we don't have the vertex. This isn't in vertex form. It's okay, you can find it. So the axis of symmetry, remember we just said the x value is your h for your vertex. So the axis of symmetry, what x equals, is your h value for your vertex. So we're going to do negative b over 2a. That's going to give us the x value of your vertex. And then we're going to plug that in to the function, and that's going to give us the y. So that's what this means. It means negative b over 2a, plug it in for the function to get this value. All right, another thing that's great about standard form is they give you the y-intercept. It's c. So this number right here being added, we know that that is a y-intercept as well. So let's find our x value. So we have x is equal to negative b over 2a. Miss Gill, where's the a, where's the b? Right here. So you have this equation. So a is the coefficient with the x squared, b is the coefficient with the x, c is the constant. Now, keep in mind, this is a negative. So when we do b, b is actually negative 6. So you can think about it as the opposite of b. So the opposite of negative 6 would give us positive 6. So that's a way to think about it too. Now we're going to plug in a. A is 3. And we get negative 6 is positive 6. 2 times 3 is 6. Divide those, we get 1. So right now we know that our vertex is 1 comma something. So how do we get that something? Plug in 1 into the equation. So I want you to pause the video now and do that. See what you get. And then plot your vertex. All right, so you should have gotten negative 2. So now we know our vertex is 1 comma negative 2. So let's plot that. All right, and it says label it. So let's label it. We have 1 comma negative 2 vertex. Just in case. All right, so now we need another point. Well, we know the y-intercept is 1, so we know it is 0 comma 1. So we're going to go up here. We got 0, up 1. But they do want us to label the axis of symmetry. So remember, axis of symmetry cuts through the vertex. All right, our axis of symmetry cuts through. This is where x is equal to positive 1. So now if we know the y-intercept is 1 point away from the axis of symmetry, we know another point here. Now because our graph is so low, we got all this space up here. Let's do another one. So you got two options. You could go with positive 3. You could go with negative 1. I like positives better, so I'm going to go with 3. If you want to do negative 1, that is fine. You should get the same answer. So go ahead, plug that into your function, see what you get. So pause the video now. All right, so regardless if you plugged in negative 1 or you plugged in 3, you would have got 10 as your y value. So we go up here, 3, 10, right? Yep. So we know this is 2 points away, so if you got negative 1, that's why you would have gotten 10 as well. And then we connect our dots. Why is our graph so skinny? Because it was stretched by a factor of 3. All right, we labeled the vertex, we labeled the axis of symmetry. We are good to go. Let's move on to the next question. All right, so important note. Because the vertex is the highest or lowest point on a parabola, its y-coordinate is the maximum or minimum value of the function. The vertex lies on the axis of symmetry, so the function is increasing on one side of the symmetry axis and decreasing on the other side. All right, so something I want to note as well. We just talked about the vertex, its y-coordinate is your maximum or minimum value. This same value will also help you with your range. All right, so I want you to make a note on your paper that the maximum and minimum relates to your range. So that means if you're asked for the range and you know the maximum and minimum value, you can state the range just by knowing that value. And remember, that's also the y, yeah. Okay, Miss Gill. the y value of your vertex is your maximum minimum. It's also what you use for your range. That's what I was trying to say. Okay, moving on. Finding a minimum or maximum value. So if you look on the other side, we talked about the minimum and maximum value. Note that you're doing the same thing we did before. And they also talked about the range. They talk about increasing and decreasing. So if your parabola opens up, you decrease first, then you increase. If your parabola faces down, you increase first, then you decrease. All right, so just a reminder. All right. So we're going to find the minimum maximum value, then we're going to find the domain and the range of the function, and when it's increasing and decreasing. And notice there's no graph here because we can actually do this without a graph, okay? So find the minimum or maximum value. Well, are we going to have a minimum or a maximum? Well, our function is positive. So that tells us that our function opens up, right? If your function is positive, it opens up. So that means you have a minimum. If your function was negative, it would open down. That would mean you have a maximum. Okay. So how do we find the minimum? Well, we need the y value of our vertex. So remember, we find the x value of our vertex by doing negative b over 2a. So negative 2, or you could think about it as the opposite of 2 is 2. Then we got 2 times 1/2. Well, 2 times a half is 1, right? A half of 2 is 1. And so 2 divided by 1 is 2. So that's the x value of our vertex. All right, so now we know vertex is 2 comma something. So we're going to plug in 2 to find our something. So pause your video now, plug in 2, see what you get. All right, so you would have got 2 squared is 4, a half of 4 is 2, 2 times 2 is 4. So 2 minus 4 minus 1 would give you -3. So we know our vertex is 2, -3. We know we have a minimum. So we can say our minimum value, minimum is -3. So we know that. All right. We can also state the domain because the domain of every single quadratic function facing up or down is the same. It's all real numbers. So our domain is all real numbers. We know our range because of our vertex, right? I told you that's your minimum value. So if we have a minimum, that means our y values are greater than the minimum y value. So we would say our range is y is greater than or equal to -3. So if you had a maximum, it would be less than. All right, then they want us to talk about increasing and decreasing. So it increases and decreases. So if we have a parabola opened up because we have a minimum, then we know it decreases first and then it increases afterwards. All right, so this is where our axis of symmetry would be, which is 2. So it decreases before 2 and increases after 2. So it decreases when x is less than 2 and it increases when x is greater than 2. See, y'all thought that lesson 1.5, y'all were done with this. Nope, I told you guys, this stuff just keeps coming back. So that's why it's important to learn it when you can. All right. Again, if you have questions on any of this, if it's just a simple question, make a note on the side of your paper to ask me when you come into class. All right, graphing quadratic functions using the x-intercept. So you may remember intercept form. It's also called factored form sometimes. So if you ever hear factored form, that's the same thing. So this is our intercept form, and we know that our x-intercepts are p comma 0 and q comma 0. So notice that it's negative. So the same idea with the vertex form, it's the opposite. So if it's x minus a number, your x-intercept's positive. If it's x plus a number, then your intercept would be negative. So let's just get into it. That way we can make this video short and sweet and to the point. So we're going to graph this using the intercepts. So first, let's just state our intercepts. They give them to us right away. So we know that one of them, if it's x plus 3, that it's -3 comma 0. And we know the other one, if it's -1, it is +1 comma 0. Go graph them on your graph. All right, so it says label x-intercepts vertex axis of symmetry. So we need the vertex. We can't do that negative b over 2a thing in here because this isn't in standard form. It's in intercept form. So what we can do is find our axis of symmetry by knowing that these two are the same distance away from the axis of symmetry. What you could also do is take your two x-intercepts, add them together, divide it by 2. So just in case you're ever unsure, this would be a way that you would know definitely. Okay, just in case you ever second guess yourself, because I know some of you guys are second guessers. So -1 is our axis of symmetry, right? If you look, that's 2 away, that one's 2 away. So axis of symmetry, and this is when x equals -1. All right, so now we need the vertex. So how do we find the vertex? Well, if we know the axis of symmetry, we know the part of the vertex. So we know the x value is -1. How do we find the y value? If you said plug it in, oh my gosh, you're a genius. You're correct. All right. Same kind of thing we've been doing. So pause the video now, go plug in -1, see what you get. So hopefully when you work that all out, you got 8. If not, here is the work. So we got -1 up to 8, and now we can draw our graph. Did we expect it to be facing down? We should have, because that negative is there. So we got our axis of symmetry labeled, our x-intercepts labeled. Now we need the vertex, which is -1, 8. All right. Any questions on that? Again, make a note on the side of your note page. Ask me in class. Last question, your favorite type. Word problems. Yay, word problems. All right, just kidding. I mean, they're not that bad. Miss Go helps you figure them out, okay? All right, so this one says the parabola shows the path of your first golf shot, where x is the horizontal distance in yards. So this is distance in yards. Just want to label that there since they didn't. All right, and then the y is your height in yards. So height in yards. So the path of your second shot is modeled by this function. So they give us an equation for the second shot. We have to answer which shot travels farther before hitting the ground, which travels higher. All right, so this one we can get a lot of information from it just by looking at it. So if you hit the ball and it landed over here, how far did it go? It went 100 yards, right? If you hit the ball and this was the highest point that it got, what is this highest point? It's your y value, 25. So we know that the first shot traveled 100 yards and the highest that it got was 25 yards. Okay, so let's figure that out with the equation. Well, first we need the x-intercept. So this equation looks a little weird, right? Because you don't see the other x-intercept. Why is that? Well, where did this one start? At 0, 0. Where are you going to start the second time? At the same place. So if it makes you feel better, I'm going to rewrite it for you just so you can see what it looks like with the 0. Okay, so this would have been the equation. If you took x and you subtracted 0, you would get x. And then that's why that's just hanging out with the -200s. Okay, so now we know just from this, how far did this ball travel? It went from 0 to 80. So this time, the second shot, it only went 80 yards. All right, so we know which shot travels farther. We know our first shot traveled farther. All right, now we got to figure out which one travels higher. So how do we do that? Well, we need the y value of our vertex. So we need our axis of symmetry. You could think about which 2 points are in, which point is in the middle of those 2 points, or we could take 80, subtract 0, divide by 2. You get 80 divided by 2, which equals 40. So that is the axis of symmetry, okay? Don't get too excited. That's the axis of symmetry. Now we have to take the axis of symmetry, plug it into our equation. Yes, we've been literally doing that with every example, I think. Taking a number, plugging it back in. So I want you to pause the video, plug in 40, see what you get for your maximum height. Before hitting the ground, because your first shot went 100 yards, your second one went 80 yards, because 80 minus 0 is 80. So which one travels higher? Well, this one went to the height of 25. We just found out this one goes to the height of 32. So your second shot went higher. So remember, you need to put those in words. I will help you out with this one, but in the future, you need to make sure with word problems, if your question is words, your answer is words. All right, so there you go. Again, just remember, if you left this on your paper like this, Miss Gill does not know that you know the answer to these questions. She just knows you know how to do some math. All right, again, you have questions, please ask in class, and I will see you guys in class.